Hi, last class we have studied about the topic from Biot-Savart's law, the magnetic field created by a finite current carrying conductor. And in today's sessions we are going to learn about applications. Last class we have learned about one application of Biot-Savart's law, that is nothing but we are calculating the magnetic field. One second. Okay. So we are calculating the magnetic field due to a current carrying conductor. So that's what we have calculated in the last sessions, and we have the formula for magnetic field intensity B equal to mu 0 I divided by 4 pi A into sine of phi 1 plus sine of phi 2. This is what we discussed. For a current carrying conductor, finite current carrying conductor, we are calculating the magnetic field will be here at this point. This is the center distance. The perpendicular center distance is called A, and this angle is called phi 1, and the reverse angle is called phi 2. So sine of phi 1 plus sine phi 2 mu 0 I divided by 4 pi A. This is what we have seen. Now we will see some problems, some sums or some numericals will be here to see how we can apply this law in the practical situations. So let's move to the first category of the question. The first question from me is, this is a current carrying conductor which is at a distance of a meter away, and B which is carrying a current of I, and this is 45 degree and this is 45 degree. This is the diagram. So here the question is, what is the value of the magnetic field? What is the value of the magnetic field? We are going to find out the value of the magnetic field at the point P. So in the point P, we need to find out the value of magnetic field. So what we can do, we can directly apply this formula, the same formula. So B is equal to mu 0 I is given as I itself. 4 pi into the center distance is given as A will be here. So 4 pi A into sine of, this is a forward angle and this is a reverse angle. So sine of 45 degree plus sine of 45 degree. So mu 0 I divided by 4 pi A. We know sine 45 is equal to 1 by root 2. So 1 by root 2 plus 1 by root 2, 2 by root 2. This we can further simplify. Mu 0 I divided by 2 and root 2 will get cancels. 4 pi A into root 2 into root 2. We can write 2 as root 2 into root 2. So then it become root 2. This we can further simplify because of this 4. So mu 0 I divided by 2. 4 can be written as 2 into 2. This 2 can be written as root 2 into root 2. So this become like this. So 1 root 2 and 1 root 2 will get cancels. So it become 2 root 2 times of pi A. This is the answer for this question. This is just a simplification, the mathematical simplification. 4 can be written as 2 into 2, and the second 2 can be written as root 2 into root 2. Okay, root 2 into root 2. So 1 root 2 and 1 root 2 get cancelled. Balance in the denominator is nothing but 2 root 2 divided by 2 root 2 into pi A. So this is a magnetic field at the point P due to the current carrying conductor called I. Let's have a look into the next question, the second examples from me. So a current carrying conductor is given like this. It's a square shaped current carrying conductor which is carrying a current is equal to I in this directions. What is the value of magnetic field at the point at this center? So you can write, what is the value of B? What is the value of B at the center? At the center. This was the question. We need to find out the value of the magnetic field at the center of the square. This is what is our expectations. So we have to solve this one. Okay. So how we can solve? How many conductors will be here? Here it's like 4 equal conductors. It's a square. Okay. Square having, we can consider like side length is equal to A. So side length is equal to A. So for this side length of the conductor, we need to find out what is the value of the magnetic field intensity that at the center. So there are 4 conductors will be there, right? Conductor number 1, conductor number 2, and conductor number 3, and conductor number 4. As we know, magnetic field is a vector quantity. If all the vectors are in the same direction, then magnetic field can be added up. If vectors are in the opposite direction, we have to subtract. Now first, if you are getting a questions like this one, first you have to decide whether it is an addition or it is a subtraction. For example, this is a current carrying conductor. From the first current carrying conductor, let me denote this as number 1, and this as number 2, and this as number 3, and this as number 4. So the 4 conductors are joined and connected to form a square shaped. So in this one, the magnetic field produced by first conductor at this point, we can apply the right hand thumb rule. Thumb is pointing to the direction of the current and other 4 curling fingers. So these fingers are coming into the board on the bottom, but at this point my fingers are coming outside. So here its magnetic field is outside because of 1, and because of 2 magnetic field is, I am holding like this, so my fingers are coming out. So magnetic field is outside, here outside, here outside. We'll see at the point 3, I am holding my fingers, here also magnetic fields are coming outside, here also it is downside, so I am holding the thumb like this downward, I'll rotating, so I'll curling other fingers, so it's outside. So all the magnetic fields created by all the 4 conductors are outside. So if you find the magnetic field created by one conductor, the idea is like this one: magnetic field created by one conductor and 2 conductor, 3 conductor, 4 conductors, all are same because it's a square shaped, and all of them we can add together. Why? Because all are directing in outside magnetic field. It's an outside magnetic field at the point P. Outside means out of the board. In my case, in your case, it is out of the paper. So let's have this one. So normally magnetic field is into the board, is representing as cross mark. Out means dot mark. So here it is out. Magnetic field is, my pen is not working as expected. Let me take another color. We'll see whether this is working. Perfect. So this is outside, this is outside, this is outside, and this is outside. So 4 outside magnetic fields will be here. Okay. So we'll redraw the diagrams like this one. Okay. So one side length is A. So what is this? This is center, right? So side is 90 degree. So one side is 45 degree, another side is 45 degree, and so what about this angle? 45 plus 45, and altogether it becomes 90 degree. Okay. So now 4 sides we have like this one. So here we have going to find out the magnetic field. So the center distance, this distance is a by 2 and this distance is a by 2. So here we have to calculate the magnetic field. So how we have drawn the diagram? We have drawn the diagram like this one, right? This is called phi 1 and this is called phi 2. From the point to this edge. So this is a point to the edge. So this angle we need, this angle and this angle. What is this angle? This is something but our phi 1, this is something but our phi 2. So what is phi 1 will be here? 45 degree. What is phi 2 will be here also? It is 45. It's 45 degree. Correct. So total is 90, here 45, here is 45, 45 plus 45, 90. So overall is 90. So phi 1 and phi 2 is equal to 90. Now we can apply the formula mu 0 magnetic field due to the first conductor. Mu 0 I divided by 4 pi. This distance we need to calculate. 4 pi. Distance to see, this is called our A, right? So in this case, this is A by 2. Distance. What is this distance? The total overall. This is A. So root of A square plus A square 2A square root 2A divided by 2. So this distance is half of this one, which means A by root 2. This is A. So we need to find out this distance. We know the basic mathematical principle: hypotenuse square is equal to base square plus height square. So hypotenuse square, which means a by a square by 2, a by root 2 the whole square, which is equal to base square, which means a square by 4, height square, I don't know, I am taking it as x. So now we will simplify. A square by 2 minus a square by 4 is equal to x. A square is taken outside. 1 by 2 minus 1 by 4, which means x will be equal to a square by 4. X is equal to, here x means height square. X means height square. So what I have to get will be there, height in the root. Height square is a square by c. This is nothing but height square. So height is equal to a by 2. Okay. So this side is also is equal to a by 2. So mu 0 by 4 pi a. A is the perpendicular distance from the conductor to that point. So here it's nothing but a by 2 is equal to sine of 45 degree plus sine of 45 degree. So 2 and 2 will get cancels, will be here. So mu 0 I divided by 2 pi a into 2 by root 2. So 2 get cancels, it become mu 0 I divided by root 2 pi a. This is the answer to this question for one conductor. So what we need to do, we need to find out for 4 conductors. For one conductor is same as for 4 conductors. Okay, so we can say total magnetic field, total B is equal to 4 times of B1, because we have only one conductor we have calculated. So we have to multiply it with 4, or we have to add like 4 times we have to add, because what is the direction of magnetic field? It's out of the board. So 4 times of mu 0 I divided by root 2 pi a. Mu 0. So 4 2 cancels. So it become 2 root 2 times of mu 0 I divided by pi a. This is the final answer. And what is the direction of this one? In your case, you can write out of paper. It is out of paper. So the magnetic field is directing towards out of the paper, not in the direction, because all the magnetic fields are same. So for example, if one magnetic field is outside and another 3 are inside, then you have to subtract highest value minus lowest value, and you have to say total magnetic field is inside. Hope you understood the concept, sir. It's a 4 conductors are given. So we are going to calculate the magnetic field due to one piece. So we have second and third and fourth will be there. So for 1, we have applied the formula mu 0 by pi a. So this is the conductor. From the conductor, this is the distance. So this is same as this one. So we are applied, we find this distance and applied. And we need an angle from this point to the edges of the conductor. See, from these points to the upper edge and lower edge. Upper edge is phi 1, lower edge is reverse one. So it is phi 1 45 and phi 2 it is also 45 degree. And we have substituted the value and we'll got the magnetic field intensity due to the current carrying, I can say a square shaped structure. Okay, hope this is clear to you. So this was the idea behind for such model of questions. Okay, fine, perfect. Hope you have noted down everything. In case if you missed something, just pause the video and go back and see if you have missed to note down. Every point should be there on your notebook. These are very important. These are very important. You can see in JE paper, you can see Neet paper, this model of question, same question, different values. So be alert and study in very conceptual way instead of learning by hearting some equations and other stuffs. Okay, let's move to the next topic. You can write on the next heading, magnetic field due to a infinite current carrying conductor. Magnetic field due to a infinite current carrying conductor. Finite we know. Infinite means infinite length. So let's know let's know if it is a finite conductor, distance from the center is A and these angles are phi 1 in the direction, phi 2 in the reverse direction. This we know B is equal to mu 0 I divided by 4 pi times of A into sine of phi 1 plus sine of phi 2. This we know. Okay, this we are very much clear about this one, right? Sine of phi 1 plus sine of phi 2. Now, what we have to see here, it's not infinite. The conductor is infinite length. So, let's have a diagram like this one, and this is going to infinity and this is going to infinity. We are going to find out magnetic fields will be here at the point here, B is equal to. Here the point is like this center distance is called A, but where I have to connect this line, I don't know where I have to connect. So my lines will go like this. My lines will go like this one. So because I don't know where to connect, this is not ending. This is going to infinite. This is going to infinity. So what is the value of this phi 1? Phi 1 is equal to 90 degree because this is not ending. I don't know where it is. So it will straightly go. So it's approximately equal to 90 degree. Similarly, phi 2 is also equal to 90 degree. You have to substitute these values will be here. Then we will see mu 0 by I divided by 4 pi A into sine of 90 plus sine of 90. 1 plus 1, 2. 2 and 4 will get cancelled outside. So mu 0 I divided by 2 pi A. Mu 0 I divided by 2 pi A is the answer for the infinite conductor. So for an infinite conductor, phi 1 equal to 90 degree, phi 2 is equal to 90 degree, and we have substituted the values and we got mu 0 I by 2 pi A. Next, what will happen? This is the expression for magnetic field due to an infinite current carrying conductor. Both top side and bottom sides are going to infinity. Now what we are going to see means it's such special cases. Okay, so it's a special case. What's the special case is talking about? If you have a conductor and that conductor upper part is going to infinity and lower part is fixed. So this is going to infinity. So if you ask me to choose a point will be here, I'll choose this point. Here I want to find out the magnetic field at the point P. So I need an phi 1 angle, I need an phi 2 angle like this one. So the phi 1 will be get shooted up. I don't know where it will get end, it will go ahead. But phi 2 is fixed like this one. Now if you take this one, this angle is called our phi 2 and this angle is called our phi 1, which is equal to 90 degree. So the point you have to remember, wherever it is going to infinity, that particular angle you have to take in as 90 degree because it will never end up, right? So it will go like this. So where it will end, we don't know. So phi 1 equal to 90. If you substituted, that formulas will be here. So B equal to mu 0 I divided by 4 pi A into sine of phi 1. Phi 1 is 90, sine 90 plus sine of phi 2. Sine of phi 2. So here the point is like phi 2, so comparable to phi 1. Phi 1 is a 90 degree and it's going to infinity. This is at some middle point. Okay, middle point, this formula is applicable. Now you assume a situations, this is an infinite conductor and which is going to infinity. This is case number 1, infinity. But you are going to calculate the magnetic field around will be here at one edge. I can say at one edge. At one edge, if you are going to calculate the magnetic field, then what is this value? So here we have one line and this is a perpendicular line. So here we have something called your phi 2. So phi 2 is approximately equal to 0 and the phi 1 is equal to 90 degree. In that cases, what will be the formula come? Mu 0 I divided by 4 pi A. Sine phi 1 is 90 degree. So sine 90 plus phi 2 is sine 0. So sine 0 is 0, sine 90 is 1. So your formula is mu 0 I divided by 4 pi A. So remember this. Okay, so this is another one. So what we are going to do means magnetic field due to an infinite current carrying conductor we are calculating. If it is a finite length, mu 0 I by 4 pi a sin phi 1 plus sin phi 2. If it is an infinite length, then phi 1 is going extending, phi 2 is also getting extending. So it has not an end. We don't have a definite end. So phi 1 equal to 90, phi 2 is equal to 90. Substituted here, you will get mu 0 by I by 2 pi a. Now what will happen if it's at some point and phi 2 is given to you? Phi 2 is exclusively given to you in the question and phi 1 is 90 because other part is infinity. You have to use this formula. Suppose it is very closer to the edge, at one edge, closer to one edge, at one edge or closer to the edge. So phi 2 is equal to 90, it's very negligible value, some 3 degree, 4 degree, something like that, or it's less than that. So phi 1 will be equal to 90 degree because it's going to infinity. So at one edge mu 0 by 4 pi a sin 90 plus sin 0 mu 0 I divided by 4 pi a. So this is applicable whether it's a lower edge or it's an upper edge. If it is upper edge, I mean the upper edge means upper edge is fixed and lower is going to infinity. So in short, if it is at one edge mu 0 I divided by 4 pi a. So two cases I described. So if the edge values are given to you, you have to apply this formula. You know sin 90 is 1. But in case of if the question is given, it's very closer to at any one of the edge, then the point is like mu 0 I divided by 4 pi a is the right answer for this questions. Okay, hope this is clear to you. Now we will see some conceptual based questions based on the finite or infinite type of conductors and how this can be we can apply will be here. Okay, so let me take one questions will be here. Okay, hope this is clear to you. We will see some interesting questions and yeah, that is important to analyze. Okay, whatever we have learned is correct and whatever our concept is thorough. Okay, so hope this is clear. Hope you understood how we are calculating the magnetic field at various points due to a current carrying conductor. Now we will move to little bit advanced problems and this is important. Okay, so let me take one example. Suppose I have a current carrying conductor and that current carrying conductor is carrying a current I. The question is given like, from the center at a distance of a meter away along the lines of the conductor, what is the value of magnetic field? Along the direction. Okay, so here current carrying conductor is I. The question is, what is the value of B due to I? So what is the value of I due to Y? What is the value of magnetic field due to the current? So I is given, okay, and magnetic field is along the lines of the conductor. So if you see like this one, see I will be there. This is called a DL, current element, and this is my distance vector. So in our basic formula, mu 0 by 4 pi into I dl cross R divided by R cube. This is a very fundamental formula to calculate the magnetic field intensity. dl is a vector quantity, R is a vector quantity. This we have written as in scalar format mu 0 by 4 pi into I dl sin theta divided by R square we are writing. What is theta will be here? Theta is the angle between dl and R. So the theta is the angle between dl and R. So dl is in this direction and R is the distance also along in the direction. So theta will be equal to 0 degree. So when theta will be equal to 0 degree, the magnetic field B is also equal to 0 degree. Important. Because if you are calculating the magnetic field along the line of the conductor, along the line means dl and R, this is nothing but our R distance. Okay, if both are in the same directions, then theta will be equal to R. So theta in between, you can write theta in between dl and R. This is nothing but my dl and this is nothing but my R. So dl and R, and we will got the angle between dl and R will be equal to 0 degree. and the magnetic field will be equal to 0 because both are pointing in the same direction and magnetic field is given raised to 0. Okay, because it's pointing in the same directions. Whenever the direction will be, whenever if it is taking in some other angles, then phi 1 and phi 2 will come into picture. Here there is no phi 1 phi 2 statements will not be there, but in case we have only this value of dl and r will be there in the pictures. So based on the dl and r value, if both are pointing in the same directions, then the value of theta will be equal to 0 because the angle between them, angle between dl and r in the same direction. So theta equal to 0, sine 0 is 0, so the magnetic field will be equal to 0. This is a concept behind this questions. The question may ask in a different way, different format or different situations. So this is one of the category of question, and we will see the next category. Okay. So the concept is important, how you are applying the concepts in all the situations that matters will be here. So let me take an example. Okay, so listen very carefully. The next questions to you is, okay, a current carrying conductor is given which is carrying a current is equal to I. I need to find out magnetic field at this point, which is at a distance of d meter away from the first conductor. And from here the angle is 60 degree. Angle is given as 60 degree. Okay, we need to find out magnetic field at point P. See, this is a conductor, this is a finite conductor, so we need to find out at the point P. So you can write what is the value of the magnetic field B at the point P. So what is the value of the magnetic field at the point P? Okay, so value of the magnetic field at the point P is really required to find out will be here. So what we can do in these cases? So we need to redraw the diagram. Okay, this is a question diagram, do not repeat it here. So let me draw the same diagram once again will be here. I am going to find out the magnetic field at the point P. Somewhere will be here the point P. Okay, this angle is how much given? 60 degrees given to you. Fine, perfect. And this distance is given as d. Okay, so we have the formula B is equal to mu 0 I divided by 4 pi a into sine of phi 1 plus sine of phi 2. A is the perpendicular distance from the conductor. See, in this conductor, if you are extending this conductor, then this is the perpendicular distance. I need to get this distance. Okay, how I will get this distance? This was a questions will be here. So for that, two things has to be given. Okay, sorry for this. And here it is 30 degree. This is given in the question. Here it is 30 degree. Okay. Not 30 degree. 60, 90, 30. If 20s comes there, let me think about 1 minute what angle will be best suited so that we can apply sine and cos in a very perfect way. So this angle is d means 60, so sine 60 you can take, but if you take cos 20 70 will come. So in that cases it will be difficult for you to choose the values. Okay, perfectly fine. And 60, 30, if it is 30, no, it should not be 90, right? Okay, so let me take this angle as something called some 45 degree to make the life easier. We'll make the angle is like 45 degree. Okay. 45. Okay, so perfectly. So if this angle is given as 45 degree and this angle is also given as 40, okay, this angle will not be given to you. So in this cases, okay, not for that angle, okay, this angle given in the question, okay, 30 degree, for example, 30 degree. So this angle is given as 30 degree. Okay, this angle is given as 30 degree. This is as a part of question. So they ask us to calculate the value of magnetic field at the point P. 30, 40, 60, okay, this is perfect. Okay, so 45 degree, and so this is a diagram and the current will be carrying, and we need to calculate the magnetic field at the point P, and this is from the center at a distance of D, and this is 30 degree, and this distance from the one edge is given as D. Okay, now we have to replace each terms will be here. For that, listen very carefully. Mu 0 I, no problem, because I is the current carried by the conductor. I is here also. 4 pi A, A is the perpendicular distance. A is the perpendicular distance. So this is the perpendicular distance, right? This side is called D. So what is this side is called? This is nothing but our A. A is the perpendicular distance. Okay, normally we know, right? This is called the perpendicular. So this is what we need, A. A is perpendicular distance from the conductor. So this is a conductor and we are taking perpendicular distance from the conductor. This is our A. A is equal to D cos theta. Theta means how much will be here? Theta. Theta ku pakkathil irukana side. Very nearer to theta is called D cos theta. D cos 30. What is cos 30? Root 3 by 2, right? Root 3 divided by 2. So we got A. Next one is phi 1 and phi 2. Okay, phi 1 and phi 2. That is important. So you need to calculate the value. So phi 1 and phi 2, let's listen here very carefully. Phi 1 is in this direction, phi 2 is in this direction. Okay, from the center to this point. So this is a center line and to that point. So first line we have to calculate and second line also we have to calculate. So from the center to the first edge, and this is the first point. Okay, this is like the first point and this is like the second point. So once we are calculating, see, listen very carefully will be here. One, from the center to this edge it is 1. From the center to the next edge is 2. So listen very carefully. From the center to the first edge. From the center to the first edge. 30 plus 45. 30 plus 45. From the center to the first. This is the first edge. This is the second edge. From the center to the first edge. First edge is clockwise direction. Okay. So I can say phi 1 will be equal to 75 degree. Phi 2 means what? From the center to the next edge. From the center, upper edge and lower edge will be there. So from the center to this first edge, and from the center to the next edge, second edge, in what direction? Anti-clockwise direction. So here the major mistakes all the students will do means they will take 30 degree. It's not 30 degree. From the center you have to take in anti-clockwise direction till here. Anti-clockwise directions till here. So you have started from here, here you have to go and in this directions. Okay, so how much will be the angle for this one in this cases? See, this is a full circle, right? So from here it is 30 degree. From here it is 30 degree. So we are moving from here. Let me take maybe. Okay, let me make this to be a little bit bolder lines to understand what we have done will be here, and this is the angle I need to take. This is okay. This is the forward direction, and from the center I need to take this value. I need to take this value. Okay, this value. This value is called this value. This value is called a phi 2. And only the first line is called phi 1. Phi 1 from the center, clockwise direction, 45 degree. From the center, anti-clockwise direction, in the reverse order. In the reverse order, you have to take. See here, this is like a if it is a full circle, if it's a full circle, then 30 will be extra. So what is the value of phi 2 will be here? Total a full circle is 360 degree, but here 30 is minusing, so it become 330 degree is comes as the answer. Now we got all the values, we'll substitute. B equal to mu 0 I divided by 4 pi a into sine of phi 1. Phi 1 means, I told, from the center, from the line in this directions. So in this directions to the first conductor. This is the first and this is second. So sine of 75 degree plus sine of 330 degree. What is the value of A? A we already calculated, right? D root 3 divided by 2. Once you substitute, all these values are here, you will get the correct answer for this questions. That's all. Okay, don't worry. Sine 75, sine 60 plus sine 15, the values will be given to you in the question paper itself. Sine 330, if that is a question, you can write sine 360. What is sine 30? Just for an additional information, what is sine 360? Sorry, sine 330. Sine 330 is equal to sine of 360 minus 30. What will come? Minus sine 30, not plus sine 30. Why? Because we know all sine t coffee. Here cos will be positive. Sine 330 means the fourth quadrant will come. This is the first quadrant, all sine t coffee. We learn it from school itself, right? All sines t coffee. So cos will be positive, will be here, but all will be positive, sine will be positive, tan will be positive, cos will be positive, but here it's, the cos is not positive. So the 330 means it comes in the fourth quadrant, so sine is negative. That's what sine 360 minus 30 is minus sine 30. That's what minus is coming will be here. Hope you understood. This is a very fundamentals in mathematics, but in case if somebody don't know, I just repeat it for to know the to get a grassroots level knowledge. Okay, so magnetic field intensity, while you are calculating, you should be alert. What is the value of phi 1, what is the value of phi 2, that is the important. And what is called A is the perpendicular distance. In this question, the beauty is like they have placed the point P instead of will be here at this point P. So we need to calculate the perpendicular distance. This distance I want, this distance, that is called A. Next one, what is called phi 1? Phi 1 is clockwise, phi 2 is anti-clockwise. That concept definitely will be there in your mind while you are applying Biot-Savart's law. Okay, so we have concluded the Biot-Savart's law. We have learned about the concept of Biot-Savart's law, ideal sine theta by r square in scalar format, I into dl cross r divided by r cube in vector format. And there we have learned about what is called an finite conductor, magnetic field due to a finite current carrying conductor, mu 0 I divided by 4 pi a into sin phi 1 plus sin phi 2. Phi 1 is in this direction, phi 2 is in the reverse direction. A is the perpendicular distances. These things we learned. Then we learned about infinite conductor, mu 0 I by 4 pi a. If it is for a infinite conductor, both the sides are infinity. If one side is infinity and closer to one edge, then mu 0 I divided by, how much will come? Mu 0 I divided by 2 pi, 4 pi a will come. If one side is infinity and other side is fixed. And we have seen some examples like square, a best application of a Biot-Savart's law, and just a simple conductor we have seen like 45 degree, 45 degree. Then we have seen this example. This is a very tricky kind of questions. Normally you can expect for those who are going to write like the very much competitive examinations, you can expect this questions. This is another rank deciding questions, because the majority of the students who are learned in by heart way have a high chance to get a negative marks. So never goes to negative marks. Understand each terms which is given will be there. A is the perpendicular distance, not a D. A is not a D. A is a perpendicular, D cos 30. First point. Second point, phi 1, phi 2. From the center, phi 1 in this direction. Phi 2 is to the next conductor. This is my first conductor, so I have to take phi 1. This is my second conductor, so I have to take phi 2 in this reverse direction. This is a very fundamental question, and this is a rank deciding questions for both for your JE, main and advanced also. There are lot of tricky questions can be derived based on the concept. Hope you understood today's sessions, and we have wind ups with the Biot-Savart's law and its application. The second part of the Biot-Savart's law is over.